In this video, we're going to be discussing this math problem here from the MOEM's math competition, Mathematical Olympiad for the middle school division. This here is a pretty easy and simple to figure out casework problem, but it requires some creative thinking to figure out. Here's the statement. A 4x6 rectangle is partitioned into 1x1 squares. Then, two opposite 1x1 corner squares are removed, resulting in the figure below. How many squares with integer length sides can be found using the line segments in the figure? So basically what they're asking here is how many squares can we create by connecting line segments in here? So for example, we get a different color. This here, if I were to outline this, would be a square made using the line segments in this figure. So that's an example of one. Now, of course, it would be quite hard and quite cumbersome to go through this entire figure and draw lines over every single possible rectangle that would be required, just not even breaking anything up. That would be very error-prone, and you'd likely get the wrong answer anyway. So the solution here is to use a little bit of casework to help to divide up your square sizes, and then add them up later to get your final answer. So let's start with the smallest size, 1x1 squares. These are going to be the very smallest ones, and they're going to be of this size, the individual squares. For this, it's pretty simple. All I have to do is just go through this thing and count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22. That gives us 22 1x1 squares of the smallest size. Then we go to the next size, which is 2x2 squares, which look like this. Now, if you're highlighting them and outlining them in a different color like this, it makes it pretty easy for you to view and see which or how many squares there are in the figure. And you can just keep overlaying lines, 2, 3, 4. Then you don't even have to outline them once you know what they look like. That's 4 down there. Then you can see, oh, here, this is 5, 6, 7, 8, 9, 10, 11, 12, 13. Just kind of moving your outline around to get 13 2x2 squares. Then we move up to the next length, which is 3x3. And this is going to be of the size, here, this entire thing, 3x3. So that's 1, then you move over the entire outline to the left, that's 2, clarity, that's here, 1, 2, 3, then move it down, 4, 5, 6. That's a total of 6 3x3 squares, pretty easy to see. Then we've got one more size, which is the 4x4 square, and there's going to be only one of these, because, as you can see down here, we're starting over here, 1, 2, 3, 4, 1, 2, 3, 4. That's a 4x4 square. This entire thing right here in the middle. And that's the only one because we removed the corner squares, and we can't fit another 4x4 square on this grid. Thus, there is only one 4x4 square. Then we found all the side length squares. These are the 4 cases here. All we have to do now is add up the sum of the squares for each case. That's 22 plus 13 plus 6 plus 1, which gives us a total of 42. So that is the total number of squares with integer side lengths, and they say integer because that means you can't have diagonal squares, because diagonal squares would have non-integer square root side lengths. Integer side length squares total to 42 here that can be formed using the line segments in the figure. Not rectangles, just squares. That's a total of 42. And that's how you'd answer this MOEM's math competition casework and geometry problem.